Hello children, welcome to our class Units and Measurements. Chapter 2, we are going to learn units and measurements. In that, physical quantity, fundamental and derived quantities, units, fundamental and derived units, SI units, and definitions of fundamental SI units, measurement of length, that is in large distances and small distances, measurement of mass and measurement of time, accuracy, precision of instrument, and errors in measurements, systematic errors and random errors, dimensional formulae, equations, all in that about full units and measurements we are going to learn from this unit, right? So why we need to know about the measurements? See, the measurement, which is nothing but physics, is an exact science which gives an accurate knowledge about the nature and the natural phenomena. It expresses various natural phenomena in terms of the relationship among the quantities which involved. See, what is physical quantity in that? See, a quantity which is measurable is called physical quantity. That means it can be measured directly or indirectly, right? And in terms of which the laws of physics. In that we have fundamental quantities and derived quantities. Physical quantities are two types. So what is fundamental quantity? A physical quantity which is the base and cannot be derived from any other quantity, which is called fundamental quantity. That means it can be treated as independent of other physical quantities, right? For example, see, we have that minimum of 7 fundamental or base quantities. These are length, mass, time, electric current, temperature, luminous intensity, and the amount of substances, right? So what is a derived quantities? A physical quantity which can be derived or expressed from the base or the fundamental quantities, which are called derived. That means what? See, it operates. The operations are based on other physical quantities, right? So that are all physical quantities than the 7 base quantities, we can call it as derived. We said that are all speed, velocity, acceleration, force, momentum, torque, energy, pressure, what are all they given. So these are all the derived quantities. See, units. Before you are going to know the units, what is measurement? How can we measure? The measurement of a physical quantity is the process of comparing this quantity with the standard amount of the physical quantity with the same kind, which is called its units. See, units, which is nothing but a measurement of any physical quantity which involves comparison with a certain basic, arbitrarily chosen, and internationally it should be accepted reference standard called as units. So what are fundamental? Here fundamental and also the derived, right? So the fundamental units. The units of the fundamental or base quantities are called the fundamental base units. That means which we are using for the distance, meter, for that time, second, mass, kilogram, like that what we have to know to measure the fundamental quantity. For that we are using that fundamental base units. What are derived units? See, the derived units, which is nothing but the units of the derived quantities which can be expressed from the base or the fundamental quantities. See, for example, you want to know speed, right? The unit of speed. What is the formula for that? formula is what? Distance travelled by time taken. So unit of speed, which is equal to unit of distance by unit of time. What is unit of distance? We know that from the fundamental. Yes, meter per second. So it will come meter per second, the first one. Like that we have a different derived quantities which has come from and connected, derived from the fundamental quantities, all other quantities. Got it? The next one is system of units. What is system of units? A complete set of units which is used to measure all kinds of fundamental and as well as the derived quantities which are called a system of units. What are the characteristics of the system of units? See, a unit selected for measuring a physical quantity must fulfill the following requirement, which are nothing but it should be first well defined one, and it should be suitable size, which is it is a convenient size. That is, it should be neither be too large nor too small as comparison to the quantity to be measured. It should be reproducible at all places, and it should not change from place to place or time to time, right? It should not change with the physical conditions such as temperature, pressure, like that, right? It should be easily accessible, we can say, and it should be acceptable also. Internationally it should be acceptable, right? So what are the various system of units which we have? In earlier time, various systems like FPS, CGS and MKS system of units were used for measurements. See, they were named so from the fundamental units and their respective systems. That is, what is FPS, the meaning, and the CGS, MKS we can see first. That is foot, pound and mass, right? That they can take for the FPS. CGS, which is nothing but it based on the centimeter, gram and second. From that they have taken CGS system as the fundamental units of length, mass and time respectively. Okay, what is the MKS system? The system is based on the meter, kilogram and the second as the fundamental units of length, mass and the time. Understand? So these are the things which is given in the tabular column: the quantity, dimension, system of units. How can be used? So FPS, CGS, MKS, which are all the quantity for the length, time, mass, right? So system, SI units, the abbreviation of the SI units, which is nothing but the International System of Units. See, SI abbreviation, which is System Internationally de Unites. So that is the abbreviation, right? So the SI units, the SI system with standard scheme of symbols, units and abbreviations was developed and recommended by General Conference of Weights and Measures in 1971. In 60s itself they started these things by observing. They got it finalized by 1971 for international usage of scientific, technical, industrial and for the commercial purpose of work, right? So the next one is, we can see the fundamental units in SI system. What we said, that 7 main fundamental units and we have 2 supplementary quantities units which we have, that you are seeing in that tabular column. That is for the quantity. For that quantity it has the symbol and the SI unit. SI unit symbol also we have. Standardized things, we have these things, right? We are following from 1970s. See, main units, what we said already: length, mass, time, electric current, temperature, intensity, amount of substances. For that symbol, see the symbols length L, we know that. From the class 6, the earlier stages of your studies, you people are using these symbol, right? Mass M, time T, current Ampere. So that the SI unit Ampere, for that we are using A, right? And Q also we are using, is it right? Charge Q, for that we are using current A, Ampere. Kelvin, temperature K. So because of Kelvin. So we want to honor the scientist, physicist, so that we are using that name. And intensity, Candela, so CD. Like that, the symbols, all these things which is on the screen, you can read, right? So the next one is the definitions of SI units. One by one we can see the 7 basic SI units and the definitions as follows, right? Meter. So that, what is the symbol? That M, right? The meter is the length of the path traveled by light in vacuum during a time intervals of 1 by 299, 792, 458 of a second, right? Kilogram. The kilogram is equal to the mass of the international prototype of the kilogram kept at International Bureau of Weights and Measures at Serves near Paris, right? Second. The second is the duration of 9, 192, 631, 770 periods of the radiation corresponding to the transition between the two hyperfine levels of the ground state of the cesium-133 atom. See, these are the base definitions. Ampere. The ampere is that constant current which it maintained in two straight parallel conductors of infinite length of negligible circular cross section and placed 1 meter apart in vacuum. It would produce between these conductors a force equal to 2 into 10 power minus 7 Newton per meter of length. Kelvin. The Kelvin is the fraction 1 by 273.16 of the thermodynamic temperature of the triple point of water. Candela. The candela is the luminous intensity in a given direction of a source that emits monochromatic radiation of frequency 540 into 10 power 12 hertz, and that has a radiant intensity in that direction of 1 by 683 watt per stadium. Mole. The mole is the amount of substance of a system which contains as many elementary entities as there are atoms in 0.012 kilogram of carbon 12, right? So these are all the definitions of base units, SI units. Okay, so upcoming class we can see various units about the measurements, right? Thank you, children.